This lesson is on the law of sines. Now our objective is we want to find missing measures in triangles without a right angle. We usually have two options when that's the case. The law of cosines, which we'll do in a later lesson, and the law of sines. We use the law of sines when we're given at least one angle, and then we're given at least one of the sides opposite one of those angles given. So in our triangle, if we have an ABC triangle with the sides opposite being the little letter, if we're given angle A and angle B, we have to be given at least one of those sides, either little a or little b, in order for us to use the law of sines. And the law of sines is sine of the angle over the side. And that ratio is always the same no matter which angle and side you choose. So sine of A over A is going to be equal to sine of B over the side opposite it, B, or sine of C, that angle, and over the side opposite it, little c. So let's go ahead and try this problem. This problem I've set up for us here, this is triangle FHG, and on this triangle I'm giving you that angle H is 32 degrees, that measure of angle F is 39 degrees. Now we have to be given either side H or side F opposite them, and so I'm giving you side F, 40, which is opposite the angle of F. So what we want to do is, first of all, set up our first proportion. We want to use the information given here, and since we're given angle F, let's go ahead and set up sine of 39 degrees over the side opposite at 40 is equal to the sine of the angle, the other angle that's given to us. So it's sine of 32 degrees. And what we're going to do is we're going to find little h, which is the side opposite that angle h. So when we do that, we're going to go ahead and do our, if you remember when we've solved proportions, you can multiply by the denominators on both sides, or in essence that means you're going to do product of the means equals product of the extremes, the 40 times the 32, sine of 32, equals h times the sine of 39. Now, once we've got this, there's only one unknown, h, so let's go ahead and divide both sides by sine of 39. So we get 40 times sine of 32 degrees over that sine of 39. And now we can do that on our calculator. And if we were to calculate that, we would get, and make sure your calculator's in degrees in this case, h then would be approximately equal to, in this case, 33.7. Now, be careful. A common error people use is they look and they say, hey, I've got a side H and I've got a side F. Let's use the Pythagorean theorem in order to come up with the other missing side, which is little g. Well, we can't do that because this is not a right triangle. Right triangles are required for the Pythagorean theorem as the given part, so we have to use the law of sines again. So I'm going to use my original, try to use the given information as much as possible. So I'm going to use sine of 39 again over that 40, which is given to us. And I'm going to set it equal to, now trying to find the g, I can calculate out what angle g is by taking 180, so the measure of angle g equals 180 minus the two given angles, so 39 and minus 32, and when I calculate that, I get the measure of angle G as 109 degrees. Now I can use that angle in this, this ratio proportion. This ratio that I have is sine of 109, which I now know, and I'm going to put it over the unknown side G. To solve this triangle and find all the missing parts, I now know all the angles. I'm only missing that one side. So let's do our cross multiplication. So g times sine of 39 equals 40 times sine of 109. Now, 40 times sine of 109, if we divide it by sine of 39, and what we get when we do that, when we divide that out, we get g approximately equal to 60.1. That's the length. Now let's just do a quick double check. 60.1, if this angle is 109, which by the way, it's not drawn proportionally, right? 109 is more than 90, but that's the largest angle. The largest side should be opposite it, and 60.1 is the largest side when I look at the different sides. So that's another double check, is to make sure largest sides are opposite largest angles. Now what I'd like you to do is I'd like you to pause the video. I'd like you to try drawing this diagram. Try setting up triangle ABC, putting in the necessary information, and see if you can come up with the first step of what the law of sines tells us. So pause the video and try that. So now that you've tried the problem to draw it as well as set it up, let's go ahead and work it out together. First of all, when drawing angle A is a little bit of a bigger angle. It's bigger than 90 degrees, so I'm going to draw 100 degrees here. That's angle A. Side A is 7, so I'm going to put that opposite it. If I make this angle B, then side B opposite it is 3. And then I'll make this angle C, and then this would be little c. So what we have to find is we have to find angle B, angle C, and little side C. So those are the three unknowns in this problem that we've got to calculate. So let's start off with what we're given and set up that ratio. So we're going to have sine of 100, which we're given, over the side that is given, side 7, so sine of the angle over the side opposite it, equals, now we're going to calculate B first because we're given side B. So we're going to do sine of B over side B of 3. Okay, just move this over here so it's out of the way. All right, now we'll do our cross multiplication. So I got 7 times sine of B is equal to 3 times sine of 100. Now we go ahead and divide by 7 on both sides, so you get sine of B equal to 3 sine of 100 over that 7. Now I can calculate that on my calculator, so I get sine of B equal to about, I get that to be about 0.42206, etc. It just keeps going. So that's my number there. Now to get that angle B, you do the inverse sine on your calculator. Remember, that's where you do the button that's right above the sine button by the inverse sign, and that will give us the angle value. In this case, I'm going to do it into degrees, and so I get B as about, when I do that, I get about 24.96, and it keeps going. So I'm going to round B to be about 25 degrees. So there's B calculated. So we've got one of our pieces of information. Now let's calculate out what, in this case, we'll find out angle C, where I'm going to allow you to use this angle and the original angle. This is calculated, so we prefer not using calculated values, but in the case of angles, since there's a lot of rounding involved, we're going to do the measure of angle C is about 180 minus the given angle of 100 minus the 25, so that gives us the measure of angle C when we subtract that as 55 degrees. We'll calculate that. So now we've got our two angles. All we're left to calculate here is what side C is equal to. Now we're going to go back to the original information we're given for the ratio. So we're going to do sine of 100 over the given 7. So those two values are given to us. I'm going to set that up as my sine of my angle C now. Since I want to find side C, I'll use the angle C over little c, which is now an unknown. Now let's go ahead and do our cross multiplication. So 7 times sine of 55 is equal to c times sine of 100. I'm going to divide by sine of 100 on both sides. So 7 times sine of 55 over sine of 100. And so when I calculate that, I get C is about, I get that to be about 5.825. And it keeps going again. And so I'm going to round that. Since this is to one digit, I'm going to just round that to about 6 when I round it. So I have my two angles that we're missing, my 55 degrees. I've got my my angle B, which is 25 degrees. I've got my side C, which is 6. So if you start off with a triangle that you know either you don't have a right angle or you don't know whether there is one, you can use the law of sines to solve it. Set up the ratios of sine of the angle over the side opposite it, and solve that proportion that results. Find the missing information, and you've solved your triangle.